This is AP Chem topic 2.6, resonance and formal charge. I went a little bit into resonance in the last video, but this is how you choose the best resonance structure if you're given multiple options, especially if the bond moves between different possible atoms. So resonance shows the different possible arrangements of bonds in a molecule. In reality, the true structure is a blend of all those models, and the electrons delocalize to form that blend, but sometimes you have a choice that's best or where the electrons are most likely to be found. And we can evaluate that using formal charge. So formal charge helps us identify the best choice of resonance structures. So your formal charges on the individual atoms, so you do it for individual atoms, sum to give the overall charge on the species. So we have an equation to calculate formal charge. So formal charge is the number of valence electrons for that particular atom minus half of the bonding electrons that that atom can claim, if you will, plus all of the lone pair electrons that are associated with that atom. And then there's some rules for identifying the best structure. So the best structure has the lowest formal charges. The negative formal charges are on the most electronegative atom or atoms, and then the formal charge of the same sign should not be on atoms that are adjacent. So let's look at three resonance structures of the thiocyanate ion. So here we go, SCN minus. So this is the one that if you're drawing the Lewis structure, you'd probably draw first, okay? With the two double bonds kind of evenly distributed. So, but you can also have the triple bond between carbon and nitrogen, or you could have a triple bond between carbon and sulfur. So let's evaluate these using formal charge to see what the best choice is. So I'm just gonna go to the top. So if we do formal charge here, you can see that for sulfur it's -1, and that's because sulfur has 6 valence electrons. It has 1 electron in a bond, okay, so 1 bond, and so then we count 1 electron there, and then 6 lone pairs, and so then 6 minus 7 is -1. Carbon is 0, and then nitrogen here normally has 5, and then you have 3 bonds, so 1, 2, 3, and then 2 lone pairs, so that is 0. So here we have pretty low formal charge, and then looking at electronegativity, you know, sulfur is closer to fluorine, so probably that's the more electronegative atom. So that seems pretty good. We go down to the double bond, then we've got 0, 0, -1. So again, low formal charges, -1 here, and then here your negative formal charge is on the nitrogen. So we'll need to pull up a table of electronegativities and see what the best option is. If we go down to the bottom one, this is not the best choice, and we can tell that right off the bat because here we have a +1 and a -2. So that gives us large formal charges, so we're going to pull this out as a possibility right away. So this is a periodic table of electronegativity, and you can see that the highest electronegativity is here in red, second highest is purple, and then orange. So looking at this, nitrogen does have a higher electronegativity than sulfur. So if I come back over here looking at this, that would make our best choice this double bond situation.